Okay, this final video is going to be a little bit of a refresher on the trigonometric functions, sine, cosine, and tangent, which we studied earlier in the year. How they work and what they are so that you can review these quickly and be ready to use them during the next week. So I taught you this little mnemonic to help remember them, SOHCAHTOA, and remember the things the letters stand for here, okay, are the first three letters are the three different names of the trig functions. So S is for sine, C is for cosine, and the T is for the tangent function. And again, what these functions are is in a right triangle. If I am talking about some particular angle or with respect to that angle, they are the proportions, or they are ratios of the various sides of the triangle. Okay, and to remember, so you always take the sine or the cosine, you always operate the trig function on some angle in the triangle, and it's going to be different if it's depending on which angle it is, but not the right angle, one of the two other angles in the right triangle. So it could be this angle, theta 1, or this angle, theta 2. And again, theta is just a Greek letter that we use for angles typically. So it's just a variable like x. You could say sine of x, cosine of x, tangent of x. But for angles, we use theta oftentimes because it kind of looks like a circle, I believe. So they're just expressions of the ratio between the sides in a right triangle, okay? And so they are, in fact, they're proportions. We have something equal to something else expressed as a ratio. So sine over 1 is equal to something over something. And for the sine, it's the OH. So the sine is always equal to the opposite side of the angle over the hypotenuse. That ratio. Okay, so if I take those lengths and I put them in this ratio, that number value will be exactly equal to the sine of that angle, which is opposite this. The cosine is the adjacent side to the angle over the hypotenuse. So that's A over H, and the adjacent side is the one that actually is not the hypotenuse, but does form part of the angle in question. Okay, so in this case right here, if we were talking about this angle, the cosine of this angle, then the adjacent side would be this one, in fact. And the opposite side would be this one. Okay, so it'll be flipped depending on which angle you're dealing with. But the hypotenuse, of course, is always going to be across from the right angle. Okay, and then the tangent, finally, TOA, the OA, is the ratio for tangent is the opposite side length over the adjacent side length. Okay, so this is what they are, just as a reminder. Again, it just has to do with the idea that if I have a right angle and then I change one of these other angles, if I increase this angle or shrink it, I'm going to change the proportion between the side lengths. Okay, I'm going to change this ratio of the O and the A to each other and to the hypotenuse. So in the end, this is just going to be some number based on this ratio or this proportion. So let's work a couple of examples. Okay, so here we have some example problems. In this first one, there's a plane which is taking off from a runway, and it's traveled 1 kilometer in straight line distance through the air. And it's left the ground at an angle of 20 degrees of elevation. And we want to know how high is it above the ground? What is its altitude after traveling for that distance at this angle? And so when you're using these trig functions, always remember, first of all, that you have to be working with right triangles. If you're not working with a right triangle, then these trig functions are not going to be useful, at least not in the same way, or unless you can somehow create a right triangle inside the other shape or something. So we can only use these for right triangles, and that's what this chapter is all about. And then I need to know which one to use. There are 3 of them. and I need to use a specific one in specific circumstances. So what I have to do is I have to consider what information I have and what information I'm trying to find. Okay, so there's going to be always three pieces of information. Something unknown, two side lengths, one angle. One of these things will be unknown. It'll either be the angle or one of the side lengths. And then I have to match the situation to whichever ratio applies to it. So, for example, in this problem, I think about, okay, what is the information that I have? Well, I'm given one of the angles, and I'm given the hypotenuse length. So I have an angle, I have a theta, I have the hypotenuse, and what I'm looking for, this height, this is the side which is opposite this angle. So I'm looking for the trig function that involves an angle, the hypotenuse, and the opposite side. Okay, and that is the sine. The sine is the opposite over the hypotenuse. So that's the trig function that I want to use here. So I just say the sine of theta, in this case theta is 20, is equal to the opposite side length over the hypotenuse. And here the opposite side is this variable h, its length, and the hypotenuse is 1 kilometer. Okay, and now this is just an algebra equation. So I want to solve for this variable h. So I multiply it here by 1 kilometer so that I can eliminate this fraction on this side. So 1 kilometer times the sine of 20 is equal to that altitude that we're looking for. Okay, and as far as finding the sine of an angle, for now we'll just use our calculators to do this. So you would type in, every calculator does this a little bit differently, but for example on mine I hit sine first and then the angle and then equals. Yours might be different. Hopefully you remember how yours works from earlier in the year with this. So we get 0.342. Okay, and unless otherwise specified, we'll pretty much round these to 2 decimal places. So we're going to say that the height here is 0.34 kilometers. Okay, so after a mile traveling at this angle in this direction, a kilometer traveling in this direction, the plane has gained a third of a kilometer in altitude. Okay, you might get a problem that just asks you to identify the ratios. Okay, so for example, you might just be given something like this. Sine E equals question mark. Okay, and then referring to this triangle. Well, all they're asking for here is, we don't know what E is, sure, but we do know that the sine of an angle, angle E, is going to be equal to the opposite side over the hypotenuse. So they're just looking for that ratio. The opposite side to E is 7, the hypotenuse is 25. So you would just put in that ratio here to complete the problem. Sine of E is 7 over 25. Okay, and then you could reduce it if it is reducible. This one is not. So that's our final answer here. We could then use this to find the angle, in fact, and maybe we'll do that in a moment. But for now, we're just going to fill in these ratios. Okay, and if it asks you for a cosine of E, well, that's the adjacent side over the hypotenuse, which is here 24 is the adjacent side to E, and 25 is the hypotenuse. So cosine E is equivalent to 24 divided by 25. Maybe they ask you for the tangent of D. Okay, tangent is opposite over adjacent. Well, D's up here though, not this angle anymore. The opposite side to D is 24. The adjacent side is 7. So tangent D would be 24 over 7, whatever that fraction is as a decimal. Okay, or they ask you for sine D. Well, there's an interesting thing here that you'll notice. The sine of E was 7 over 25, but if I switch to the other angle and I take the sine, well, now this is the opposite side. So I'm going to get 24 over 25, opposite over hypotenuse for sine. And this is the same as the cosine of the other angle. Okay, and this is always going to be the case. The cosine of one angle is equal to the sine of the complementary angle in the right triangle. Okay, so this one and this one add to 90. If I take the sine of this one is equal to the cosine of this one. The sine of this one is equal to the cosine of this one, okay, and so on and so forth. So the sine and the cosine flip. And the tangent, what will happen with the tangent, if we do tangent of E instead of tangent of D, is the tangent will be the reciprocal. Instead of 24 over 7, tangent will be 7 over 24 if I take the other angle, because the other side is becoming, the adjacent side for the one angle is becoming the opposite side for the other angle, or it is the opposite side for the other angle. Okay, so you might, they might give you just a fill in the blank sort of thing like this, where they say sine of this angle equals question mark, and then if you have the side lengths, well, you know it's going to be that ratio, okay, for that particular trig function. If I wanted to find these angle measures now based on this ratio, okay, again, I use something called the inverse sine. So if I have sine of E is 7 over 25, and I want to know what the angle E is, well, I have to undo, right now the sine function is operating on this, so I can't get this by itself unless I undo that sine function. And the operator that we use to do that is the inverse sine, or the arc sine. The sine to the -1 is what it looks like on your calculator. Okay, and usually this is in different colored letters on the same key as the sine, the cosine, and the tangent. So sine -1, cosine -1, tangent -1, to the negative first power, I should say. But it's not really a power, it's just the way we represent the function. So if I take this inverse sine on both sides, then E will be by itself, and that will actually give me the angle. So E is going to be this inverse sine of this ratio, 7 over 25. Okay, and if I punch that in, 7 over 25, I get 16.26, approximately. Okay, so we can use the trig functions also not only to find missing side lengths like we did here, but also to find unknown angles if we know the side lengths. So this angle would be, in reality, for this particular ratio or proportions in the right triangle, 7 to 24 to 25, this will be 16.26 degrees. And it means the other one will be 90 minus that. So 70.3 something. No, 70.74. Excuse me, 73.74. Okay, so now just some practical examples. We have here a right triangle with a 42-degree angle, and we want to know this side that's adjacent to it. Okay, so we have a hypotenuse, we want to know the adjacent side, and we have an angle. So hypotenuse and adjacent, that's from cosine. So we're going to use the cosine function here. The cosine of this angle, 42, is x over 100. We multiply both sides by 100, and we get x is 100 cosine 42. So cosine 42 times 100, 74.31 is x here. Okay, here we have two right triangles actually, or one triangle that's divided into two right triangles. We don't have enough information on this one to find x, because all we have is this one angle. We don't have any other side lengths. So one piece of information is not enough to use the trig functions. So we're going to have to see if we can find something else here. For this right triangle, we have a hypotenuse and a 51-degree angle. So that's two pieces of information. And if I could find, oops, that's x already, let's call this b. If I could find this side length on this smaller right triangle, that is also a length on this right triangle, and then I would have two pieces of information that would allow me to find x. Okay, so this is a two-part problem. Here, b is the opposite side from 51. 70 is the hypotenuse, and we have an angle. So that's SOH. That's the sine. So we want to take sine of 51 is equal to b over 70. So b is 70 sine 51. Okay, and rather than convert this to a number value yet, since I'm going to use it over here and I don't really want to round it off yet, I'm going to go ahead and just keep it like this. I'm just going to say, well, that's what b is. It's that value, 70 times the sine of 51. And I'm going to use that as my side length in this next part of the problem. So here we have now, we know the opposite side to 30, and we want to know the hypotenuse. So again, I'm using the sine once more. So now I say sine of 30 is the opposite side, which is 70 sine 51, over the hypotenuse, which is x. Okay, now here, x is in the denominator, so this is a little different than these other examples. I need to isolate x, so I'm going to multiply both sides by x so that I bring it into the numerator. So I have x sine 30 equals 70 sine 51. And now I'm going to isolate x by dividing by the sine of 30. Okay, sometimes this is confusing for students, but just remember, sine of some angle like this or any of the trig functions, it just represents a number. So this is like just having a number like 5 times x, sine of 30 times x. So we can just divide by that just the same way we would divide by any other number if it were a coefficient or being multiplied by x. So x is 70 sine 51 divided by the sine of 30. Okay, so I can do this as sine of 51, divide that by the sine of 30, multiply that by 70, and I get 108.80 for this side length value. Okay, I had to pause for a moment there because I forgot to put the side length values on this one. Now this one is a little bit trickier because remember, we have to have a right triangle in order to use these. And it's not clear that we do here immediately. But if I add these angles, 38 and 52, I get 90 degrees, which means that for there to be 180 in this triangle, this remaining angle also has to be 90 degrees. So this is a right triangle, in fact, it's just not immediately shown to us as such. Okay, so we can use the trig ratios on this. And it's my choice. I have two angles, so I can use whichever one I like. I can use the 38-degree angle or the 52-degree angle here. I'm going to go ahead and pick the 38-degree angle. So if I want to find x, well, 88 is the opposite side, and x is the adjacent side to 38. So I have O and A. Well, that's going to be the tangent function that I need. So I will write tangent of 38 is 88 O over x A. Okay, and then again, now I'm just in the stage of algebraically simplifying this and solving. Tangent 38 equals 88. Divide by the tangent of 38 on both sides. And so x here is going to be 112.63. Okay, you could also, alternatively, if you wanted to, you could use this 52-degree angle. And the way that that would change things is for the 52-degree angle, 88 is not the opposite side, 88 is the adjacent side, and x is the opposite side. So you could also use tangent there. You could say tangent 52 is equal to x over 88. Okay, and this might actually be easier to solve because all you're doing here is multiplying tangent 52 by 88. You don't have this step where you have to get x out of the denominator. But 88 tangent 52 will be the same value as 88 divided by the tangent of 38. So you get the same result either way. Okay, just a few more. We have a 3, 4, 5 triangle. Well, okay, do we have a right angle here? It's not immediately apparent. We don't have any of these angle values. But I did tell you that this is this ratio of 3 to 4 to 5 the other day. I told you that this is a right triangle ratio, in fact. So maybe I don't know this is a right triangle, but I could check it, remember, using the Pythagorean theorem. I could do this little operation where I square the legs, sum them, and then see if that is equal to the square of the hypotenuse or not. If it is, that means this is a right triangle. Okay, and here 9 plus 16 is 25, so this actually is a 3, 4, 5 right triangle. Okay, and again, this ratio 3 to 4 to 5 is very common for right triangles. So we can just kind of even recognize it. We don't even necessarily have to do this step of verifying. And I want to find the angle here. Okay, so before we were finding side lengths, now I want to know what this angle is. So I have all three sides. So I can actually use any of the trig ratios here because I know all three sides. I know the opposite, the hypotenuse, and the adjacent side. So I just need to pick one. I'm going to go ahead and pick the tangent. So the tangent of that angle is O over A, opposite over adjacent. The opposite side to this angle is 3. The adjacent side is 4. So tangent of x is 3 over 4. And again, to solve for an angle, I need to undo the trig operation. So tangent is operating on x. I need to take the inverse tangent of both sides. So this angle is the inverse tangent of 3/4. Okay, and again, once I put that in my calculator, I get 36.87 approximately. So that angle is about 36.87 degrees. Okay, and then I know this is 90, so I could also use that to find the remaining angle. Here we have an isosceles triangle, side lengths of 20 and 20. So this is not a right triangle. But I can pull a trick here. I can make a right triangle in this thing. I drop this altitude from the vertex to this side. Now I have a right triangle, okay, with a hypotenuse of 20. And in an isosceles triangle, also, if you remember this theorem we had, if I do this, if I drop an altitude from the vertex to the base, I divide the base exactly in half. So that means this piece is 17 and this piece is 17. It's 34 divided by 2. So now I can look at this single right triangle here. Forget about everything that's going on here. Now I have a right triangle with two sides and an angle. So here the sides that I have are the adjacent side and the hypotenuse. So what I want is the cosine. So the cosine of that angle x is 17 over 20. Okay, and just like with the tangent here, I now need to take the inverse cosine of both sides, which leaves me with this. And when I do this operation, I find that that angle is approximately 31.79 degrees. Okay, final example. Again, we've got two triangles here, so this is going to be one of those two-step or two-part process problems. The right triangle is, well, this larger one, but also this smaller of the two sub-triangles is also a right triangle. But again, right now I don't have enough information on it. I just have an angle and I don't know anything else about it other than that there's a right angle. But for the larger right triangle, I know the hypotenuse and I know an angle. So x is just this distance here. It's not this whole distance of this side length. So I can use this to find this altitude maybe. So I have this altitude is the opposite side to 30, and I have the hypotenuse. So I need the sine function for that. Sine of 30 is h over 100. That means h is 100 times the sine of 30. Okay, my camera ran out of juice there. I ran out of recording space, so I had to stop the video, but we'll finish this. So we determined that this altitude here for the large triangle is 100 times the sine of 30. Again, I'm just going to leave that as is, 100 times the sine of 30, because I'm not done using it yet. So I'm not going to round or estimate just yet. And once I know that side length, then I have two pieces of information in this smaller right triangle. And so I can find this side length x using that. So I know the opposite side to the 58-degree angle, and I want to know this adjacent side to it. Okay, so opposite and adjacent, that means I need the tangent. So the tangent of 58 is the ratio of the opposite side, 100 sine 30, over the adjacent side, x. And multiplied by x times the tangent of 58 equals 100 sine 30, divided by the tangent of 58. So x is 100 sine 30 divided by tangent 58, and that number comes out to be big suspense, 31.24 degrees, approximately. Okay, so these are some examples of the ways that you can use the trig functions in practice to find either unknown side lengths or unknown angles, both. And this is just very, very basic trig. When you get into pre-calculus, you will learn a lot more about trigonometry, but it's all founded on this, really. And if you have the basics down very well, then the rest of it is not so terrifying.